In our previous video, we created the targets, modified the BB gun, and now we're on to the most important part, building the controller box. The controller box is the brains of the operation. It is what will tie everything together, the props, the targets, and the rifle to make the shooting gallery work. This shooting gallery will support up to 8 targets. So how many inputs or outputs do we need for our controller? Well, probably more than you'd expect. For each target, we have to control the LEDs and receive light sensor status. For the props, we have to control 8 relays. And for the rifle, we have to control the trigger, laser output, and the vibration motor. In the next video, we'll be talking about sound, but to control the sound, we will also need another 2 outputs and 4 inputs. In total, we will need 20 outputs and 13 inputs. To support this many inputs and outputs, we will use the Arduino Mega 2560. It has over 50 digital I/O pins and will fit this project perfectly, and it's programmable to do whatever we want it to. Now that we have our controller, we will also need relays, amplifiers, digital switches, and then smush everything into this project box. I first drilled a hole in the front of the box for the rifle connection. Then I printed out the bottom plate and added threaded inserts to hold the relay board and the audio amps down. On the top of this plate, we will attach another level, and this is where the controller will sit. To do this, I printed out standoffs and attached them to the bottom plate. Then mounted the Mega 2560 on top of this with its expansion board to make adding connections easy. Now, time to start routing wires, and this is not going to be fun. Each target has 4 wires, so a total of 32 wires just for the targets will be connected into this box. You may have noticed, but I also had to add transistors for each target to control the lights. This is because a controller board can only handle 200 milliamps total power output, and we will be closer to 800 with all the lights on. We will use the transistors as a switch, and these can handle up to 600 milliamps each. Here's how I routed all the wires to the transistors. In addition to this, we had to add another high current digital switch to provide power to the vibration motor. This is a MOSFET switch and can handle up to 30 amps, which is way more than we needed. Now onto the software, which is my favorite part. We can control the trigger and the laser independently. They are tied together only through software. This means we can control how long the laser stays on after the trigger is released, or we can disable the laser output altogether. For now, a player can only pull the trigger 2 times a second, and the laser will stay on for a quarter second after each pull. So if a player does hit a target, the target lights will turn on and will send a signal to the controller. The controller will trigger the relay to turn on the prop for a set amount of time, and at the same time, trigger the sound to the prop. After a target hit, the controller will ignore the target for the next 5 seconds. If the trigger is pulled and no target sends a signal within the 250 milliseconds, then we know the target was missed, and we can play a sound for that too. And finally, while the game is idle, we can control the target lights by fading them in and out and even adding flashing patterns as seen here. Lastly, we added LEDs on top of the box to indicate power and when the trigger is pulled. After a bit of software timing adjustments, we finally had our first prop working. Yeehaw! Thanks for watching this episode. In the next one, we will go over all things audio. We will go over how we paired the sound with the props we will be using, how to input the sounds into our controller, and the logic behind the whole thing. Until then, stay spooky, and I'll see you on the next one.